partial pressure is something that we talk about when you have a gas mixture. And what we're doing is we're taking the total pressure of the mixture and breaking it into the part that's caused by each of the gases in the mixture. And for example, if you look at my gas mixture here, it has a blue gas and an orange gas. And part of the pressure is due to the blue, and part of the pressure is due to the orange. Why is that? Well, some of the collisions against the wall are due to the blue, and some of the collisions are due to the orange. And so part of the pressure is due to blue and part is due to the orange. Now let me clean this up and let's look at what's going on here. How much of the pressure is due to the blue? What percent of the pressure is due to the blue gas? Well, if you count, you'll see that there are 10 particles here, and 2 of them are blue. So 20% of the gas is blue. And so 20% of the total pressure is blue. 20% of the collisions along the container wall are blue particles. And so we can break that total pressure into 20% of it's from blue and 80% of it's from orange. Well, the thing about it is in chemistry, when we're doing math, a lot of times it's better to not deal with percents. It's better to use a fraction. In other words, mathematically, it'll work out a little nicer if we say of the total pressure, 0.2 is due to the blue and 0.8 of it is due to the orange. That kind of eliminates that times 100 when we're doing our math. Let's consider this equation down here, and let's make A the blue particles. So this, when we say the pressure due to blue divided by the total pressure, that number we said was 0.2, because the fraction of the pressure that's due to blue is 0.2. And so, let me change it to this. And so we say that's the pressure fraction for blue. Now we can do the same thing, and this time I'm going to say the mole fraction of blue. Make this blue again. Remember that N is moles, so it's kind of like we said we had 2 of the particles that were blue out of a 10 total, and we got that to be 0.2. 2 divided by 10 is 0.2. Now the thing to notice here is that these numbers are the same. And so that just says that the pressure fraction is equal to the mole fraction. And we put all of these equations to it, and they can kind of look complicated, but it's pretty easy to kind of do what we did and said, oh, well, of these, the fraction that are blue are 0.2, and so of the pressure, 0.2 of it is due to blue. Dalton's partial pressure, we didn't mention up here what it means. Dalton's law of partial pressures just says that if you add up the pressure due to the orange plus the pressure due to the blue, then you have the total pressure of the mixture. Let's try applying this. So air, we'll pretend like it's just nitrogen and oxygen, which it is mostly. What is the mole fraction of the nitrogen? Well, mole fraction, so these percents are in terms of particles. Numbers of particles, in other words, moles. So if the percent of the moles that are nitrogen is 79, then the mole fraction is 0.79. And the mole fraction does not have units. if the barometric pressure is 1.10 atmospheres, and so barometric pressure is what the pressure you would measure in the room with a barometer, and so this is a total pressure caused by both the nitrogen and oxygen. Okay, so what part of the pressure, that's what this stands for, what part of the pressure, or what is the partial pressure of nitrogen? Well, I'm just going to take the mole fraction and multiply it by the total. Okay, and where I got that 0.79 was from this. Okay, so it's just like using a percent. I mean, sometimes people don't even go through this first one. If 79% of the gas is nitrogen, then 79% of the total pressure is due to nitrogen, and that's all we did with that. Over here, I've written kind of all the math and equations, and I almost think that that makes it harder to look at that. But if you know how to work with percents, it's pretty straightforward. Okay, C. So what is the partial pressure of oxygen? What part of the pressure is due to oxygen? And there's more than one way you could do this. You could say the partial pressure of oxygen equals to the mole fraction, because it was 21%, times the total. And get it this way. Or you could get it by adding and subtracting. And it's basically this equation here, is that I would take the total, which was 1.1, and this is the partial pressure we had for nitrogen, and just solve for this one. So we're ready to practice, and so you know that you're going to use Dalton's law. Anytime you have a gas mixture, there's a good chance that you're going to use it. And then know how to apply both parts of this, that if you have a mole fraction or a mole percent, you can break down the pressure into its parts, but then also know that all of the partial pressures add up to the total.